All right. So just as a brief recap from yesterday, okay, we were talking about inverses, all right, and whether the inverses of a function are also functions themselves, okay, and we talk about relations and functions and stuff like that too. We also talk about that phrase one-to-one, right? So in a one-to-one function, no output is ever used more than once in the function's pairings, okay? So basically, one x value is paired with one y value, okay? So you should never see two x values paired with the same y value, or, of course, one x value should not be paired with two y values. That would then be not a function, okay, right? So one x value, one y value, okay? And so we looked at how to, kind of find the inverse, right? So when you have your original function and your, domain and range pairings there in the function, to do the inverse of that, you literally just flip them, right? You swap them. Y's become your x's, x's become your y's. And the relationship still holds. It's just that, -4 was the input, -2 is the output. Now it's -2 is the input, -4 is the output. So the outputs and inputs switch, but the pairing still stays, okay? In this case, right, our original function was a function. Bless you. Its inverse. Is the inverse also a function? Does every x value go to just one y value? Is this a function? Yeah, it is, okay? Every x value goes to one y value, okay? So we start with a one-to-one function, right? And it resulted in something that its inverse was also a function. Here, okay, this function we determined was not one-to-one, it's many-to-one, right? Because we have, and for example, right here, these two x values, 1 and 4, both get paired with 2. So this would be 2-to-1, okay? So it's not 1-to-1. As a result, its inverse, when we flip things around, right, 2 gets paired with 1 and with a 4. Okay? So this inverse, is it a function? No, right? The x value 2 goes with 1 and with 4. So it's not a function, okay? So it's an inverse relation of this, but not a function. Okay? So there's that, all right? Graphically speaking, okay, we can identify the inverse of a set of points or of a graph by taking these points, okay, and let's hold off on that. Actually, let me hold off that thought. So we have the function coordinates already given to us here. So to find the inverse here, right, all we have to do is just flip around the coordinates, right? So -4, -2 becomes -2, -4. Okay, 0, -3 becomes -3, 0. 1, 2 becomes 2, 1. Okay, and then 4, 1. Whoops, I messed that up. It should be 1, 4. Okay, so all we're doing there is just flipping around the x and y coordinates. If we plot these, so -2, -4, -3, 0, oops, 3, 2, 1, and then 1, 4. Okay. The book already put in this dashed line for us here, this dashed line y equals x. What do you notice about the relationship between the inverse in red and the original function points in black? What do you see as a relationship there? How do the inverse points, the red ones, relate to the black ones there in the graph? Yeah. Sorry. Let's go to Haley. Sorry, Haley.
It's a mirror image of the parent function reflected over y equals x.
Okay, yeah. And Jordan, what were you going to say?
Pretty much the same thing.
Yeah, pretty much the same thing. Yeah, that's right. It's good. Both you guys got it. Exactly. This is a reflection over the line y equals x, right? Taking this point, reflecting over the line y equals x gives us this point, right? Taking the black point right here, reflecting over the line y equals x gives us this. Taking that point, reflecting over y equals x, taking that point, reflecting over y equals x gives us those points. Okay? So, the inverse is the reflection of f of x over the line y equals x. Okay? Now, if you remember from geometry, right, you did reflect over the line y equals x. And in coordinate notation for geometry, that involved just swapping the x and y values. Doesn't that make sense? Because isn't that exactly what the function to get the inverse, isn't that what we do to the function to get the inverse? We swap the x and y values, right? 0, negative 3 becomes negative 3 is 0, right? So y is equal to x. We say that y is x, and so they swap, okay? And so this is a graphical approach, okay, to kind of see how to find the inverse of something, is to reflect the graph over the line y equals x. So either you swap the x and y, right, or you can reflect it over the line y equals x, and it gives you the same kind of result. Okay? And so we'll look at this last little piece right here. Okay? So, questions on anything so far? All right, so the composition of two functions, okay, f and g, written as f of g of x, right, f of g of x, okay, is a new function that uses the output of g of x as the input of f of x. So in other words, you're taking g, you're plugging it into f there. Okay? Okay. So, and they give an example here. More about that. But why do we bring in the idea of composition here? Is because when you compose a function and its inverse, all right, the result should just be x. I guess it doesn't really say that here, but yeah. So anyway, you'll see here, right? If we take our function here, right, and we plug negative 4 in, we get negative 2, 0 becomes negative 3, 1 becomes 2, and 4 becomes 1. Okay, but then that's the range of f becomes the domain of f inverse, and then the range of f inverse just goes back to the domain there. So negative 4, 0, 1, and 4 would be what fills in those blanks right there. Okay. And this will be true in general. Okay, so all that work really to get down to this point right here, the box. Okay, how to find the inverse of a function, right? So now we have an idea about what the relationship is with a function and its inverse, right? You take a function, swap the x and y's, you get the inverse, okay? And, that kind of thing. So here's how we actually find the inverse of a function, okay? If we have f of x equals something, we'll change f of x to y, okay? We will then solve for x in terms of y, and then swap x and y. Okay? And then we will have the inverse, that'll give us the inverse function. And I'll show you what that looks like. Okay? To check your work and verify that the functions are inverses, show that f of f inverse of x equals x, and that f inverse of f of x equals x. In other words, to show that you do in fact have inverses, to justify that you do have correct inverses here. I'm going to star this because it's important. Okay, this as well. So this is how you find the inverse. This is how you justify that you have the inverse. You plug the inverse into the original function, and you should get x. You plug the function, the original function, into the inverse, and it should also simplify down just to x. Okay? So, we have some space right there, so let's use some space here to actually do this and see what an inverse actually looks like and stuff. Okay, so let's take a look at an actual inverse here. Let's see. So let's do f of x equals 3x plus 7. Okay, we'll just stick with linear stuff here. Okay, and we want to find f inverse of x. Okay. Find the inverse. All right. So let's just follow through here. We're going to change f of x to be y equals 3x plus 7. Okay. And it says to solve for x in terms of y. I like to do step 3 first, so I'm gonna switch these two steps around. I like to swap x and y first and then solve for y. So in other words, I'm going to make this be x equals 3y plus 7. Okay, so I swap x and y, and then we'll just solve for y. So, algebraically here, what would we do to get the y by itself? Subtract 7 on both sides. You got it. Okay? And again, I'm going to show all these steps out. Eventually, I'll kind of... What's still with the y we need to get rid of? 3. So, how would I get rid of that 3? Divide everything by 3. Yeah. Divide by 3, divide by 3, divide by 3. Okay? So I'm kind of running out of space here. But I'll end up with y equals x over 3. You can leave it as x over 3 if you want to. Minus 7 over 3. Again, that doesn't really simplify, so you can leave it as 7 over 3. Other ways you could write it, you could write 1/3 x minus 7/3. Okay? If you want to make that 7/3 be like 2 1/3, that's like your prerogative. I would really encourage you, though, if you plan on continuing, that you be comfortable with these improper fractions, well, the 7/3 and stuff like that. Either one of these is fine, though. And so, and 5 and 2, or 2 1/3 would be fine if you change 7/3 to a mixed number or something. All right, the last thing we should really say here to indicate that this is an inverse is, instead of y, we'll write f inverse of x, and we'll put that x over 3 minus 7 over 3. Okay? And so there's our inverse function. Okay, just like so. Questions on any of that? So that's really all there is to it, finding the inverse. Now, let me show you the justification part. Okay? So in other words, I need to evaluate. So, okay, so now I'm going to show that they are inverses. Okay? So first thing I'll do f inverse of x. Okay, so I'm going to take my inverse function that we just found. I'm going to substitute that into my original function right here. Okay? So, my inverse function is, we'll say x over 3 minus 7/3. Right, so I'm just replacing f inverse with what it's equal to, right? What I said right there, x over 3 minus 7/3. Okay. Now, that x over 3 minus 7/3, it's replacing the x. So wherever I have an x in my function, that x over 3 minus 7/3 will replace the x. So in other words, I'm going to have 3 parentheses, x over 3 minus 7/3 plus 7. Okay, you see that? I replace the x in my original function. 3 times x, 3 times x thirds minus 7/3. Distribute the 3. So 3 times x over 3 is going to be just x. 3 times minus 7/3 will be minus 7. And what does it simplify to be? X, right? That's good, right? We want to show that that's true. And you do the same thing here for f inverse of f of x. So we plug the original function, 2x plus 7, in for the x right there, and you'll get the same result. We should simplify down just to x there. I'm going to run out of space there. Okay. Which is then, oh shoot, I messed up. Yep, messed up. Mr. Wid. Okay. Just in the interest of time, I will stop there. Okay, we'll finish this one up tomorrow, we'll just stop there and I'll finish up tomorrow. Okay. I won't give you a homework assignment tonight. Alright. Tomorrow we will finish up this last little bit of inverses, and then we'll start looking at the graph of the absolute value function too. Okay? Nope. I think you get a copy of what you're saying. No.